You know how you type something into a search bar and like almost instantly you get exactly what you were looking for?
Yeah, it's pretty incredible.
Think about it, booking a flight, finding some product online, even just refreshing your social feed.
Hmm.
Behind all that speed, all that efficiency, there are databases working incredibly hard.
Absolutely. And today we're doing a deep dive into the work of someone really key to that, Patricia Selinger.
A true pioneer. She
Hmm.
fundamentally changed how these systems operate and, well, made that speed possible.
Yeah, we've got some fascinating material here. We'll be looking at her key academic papers, bits about her career, and just why her impact is still so huge in the data world.
Exactly. Our mission today is to really get Selinger's core breakthrough. It's called cost-based query optimization,
Right.
and why it's still, absolutely crucial to pretty much every single digital interaction you have.
It really is fundamental.
Okay, so let's unpack this. To really grasp why Selinger's work was such a big deal, we need to step back a bit.
Back to the early days.
Yeah, the early days of relational databases, maybe the 1970s, around when IBM was developing System R.
Okay.
Now imagine asking a database a question. That's basically what a SQL query is,
Yeah.
right? Asking for specific info.
Yeah, a structured question.
But back then, the database didn't have a very smart, automated way to figure out the best way to get you that answer.
That's right. In those early systems, how the database actually processed the query, well, it often just followed a fixed set of rules.
Programmed in by developers.
Yeah, or sometimes it even needed manual tweaking of the query itself to get decent performance, which meant, the database might not always take the most efficient route to find the data you wanted, especially with lots of data.
It makes me think of like trying to find the quickest way across a huge country before we had good maps or GPS.
That's a great analogy.
We might have some general rules, maybe stick to the big highways, but without really analyzing all the different options, the distances, potential traffic.
You could end up on a much slower path.
Exactly. And with the massive amounts of data we use today, those slow routes would just make everything grind to a halt.
For sure. But then Patricia Selinger came along.
Right.
Her 1979 paper, Access Path Selection in a Relational Database Management System, was, well, it was a landmark, a real turning point.
Yeah.
It introduced this core idea of cost-based query optimization.
Okay, here's where it gets really interesting, I think. So
Yeah.
in simple terms, what is cost-based query optimization?
So at its heart, it's about the database automatically figuring out the most efficient strategy.
A strategy.
Yeah, the best query plan, they call it, to answer your SQL query.
Okay.
So instead of just blindly following those rigid preset rules we talked about,
Right.
the database actually starts to evaluate multiple different ways it could go about getting the data.
Like our cross-country trip, considering different routes, maybe some back roads, not just the main highway.
Precisely. And the key innovation in Selinger's work was that for each of these potential plans, the database would estimate the cost.
The cost, what kind of cost?
Well, it's a prediction. Things like how much data needs to be read from storage that's I/O, input-output,
Okay.
and also how much processing power, CPU time, will be needed for that plan.
Got it.
And then the database intelligently selects the plan that it estimates will have the lowest overall cost.
Wow. So the database itself became like its own super smart travel agent,
Yeah, that's a good way to put it.
calculating the fastest, most efficient way to get the information you asked for automatically. That's pretty elegant.
It really was, because before this, those rule-based optimizers, they often made decisions that maybe looked logical on the surface, but could be incredibly inefficient in practice, especially when you started dealing with really large, complex sets of data.
Right.
Selinger's approach let the database itself decide the optimal path, based on the actual data it had, the system's resources.
Without needing the user, you, to be some kind of database guru who knows exactly how the data is laid out inside.
Exactly. You didn't need that deep knowledge.
And that must have had a huge impact on how databases could be used, right? It let them scale up, become more user-friendly.
Totally. It's what allowed them to really scale and become much more, approachable. You didn't have to be a database tuning expert just to get decent performance anymore.
You could just tell the database what you needed.
Yes. This shift towards what we call declarative data access was a game changer.
Declarative, meaning you declare what you want.
Pretty much. You express your needs like, find me all the customers who bought product X last month, without needing to spell out the exact step-by-step procedure the database should follow.
Okay, that makes sense. Like Searching for a song online.
Perfect example. You just type in the title or artist, right?
Yeah.
You don't tell Spotify's database, okay, first look in the Pop Songs 2020s index, then check the artist name table. No.
No, definitely not.
You just say what you want. Selinger's work really paved the way for that kind of seamless experience.
And her work wasn't just theoretical papers, was it? I mean, she was actually building these early systems.
Oh, absolutely. She played a crucial role in IBM's System R project.
System R, that was a big prototype.
Exactly. It was the system that really proved that relational databases and the SQL language used with them could actually work, that they were practical for real-world stuff.
And her optimization work was key to that success.
Fundamental. Her new approach to query optimization was a huge reason System R performed well enough to be convincing.
Wow. And didn't System R lead directly to IBM DB2?
It did. DB2 became one of the first really big commercial relational databases, still a major player today.
So her ideas went straight from research into products people were actually using every day. That's pretty cool.
It is. And beyond just the core idea of cost-based optimization, her contributions within System R, well, they help shape many other fundamental database techniques we still rely on constantly.
Like what else?
Things like clever algorithms for joining data together efficiently from different tables, those are called join algorithms.
Okay.
Smart ways to use indexes, like the index in a book, right, to speed up searches.
Makes sense.
And effective ways to manage data in the computer's memory, that's buffer management. All these pieces were vital to making relational databases actually work well enough for widespread use.
It's just amazing to think that these core principles she developed way back then, they're still so central today, even with all the changes in technology.
That's what's truly fascinating, just how enduring those core ideas turned out to be.
Because databases look so different now, right? Cloud, distributed systems.
Right. Even with the massive shift to cloud-based distributed database systems, think about Snowflake, Google BigQuery, Amazon Redshift, Databricks. These platforms handle enormous amounts of data spread across tons of computers.
Yeah.
But the fundamental principles of cost-based optimization, they remain absolutely central.
So the brains behind these super advanced modern systems, they're query planners, they're still built on Selinger's foundation.
Essentially, yes. I mean, they've certainly become much, much more sophisticated, of course. They have to handle the complexity of distributed data, the sheer scale.
Yeah.
But that core concept, evaluate different ways to run a query based on estimated costs, that's still the bedrock. And her ideas also underpin many advanced features we see now, like querying data across different systems seamlessly, federated querying, or systems that handle both everyday transactions and complex analysis really well, HTTP systems.
Right, hybrid transactional analytical processing.
Yeah, and even database services that can automatically tune themselves for better performance without needing a human to step in.
Self-tuning databases.
Exactly. A lot of those auto-tuning or auto-indexing features you see in cloud databases, they are direct descendants of her groundbreaking work on making the database understand its own performance.
It's clear her technical contributions were just massive. But she was also recognized as a leader, right, for her influence.
Oh, definitely. Patricia Selinger received numerous high honors. She was named an IBM Fellow back in 1994.
IBM Fellow.
Yeah.
That's a big deal at IBM.
It's huge. It's their highest technical rank, and she was actually the first woman to achieve it at IBM.
Wow, okay.
She's also a Fellow of the ACM, the Association for Computing Machinery, a Fellow of the American Academy of Arts and Sciences, and a member of the National Academy of Engineering.
Those are all incredibly prestigious recognitions. Seriously top-tier stuff.
Absolutely. And her impact is also really highlighted by the SIGMOD Edgar F Innovations Award she got in 2002.
SIGMOD.
Yeah.
That's the big database conference group.
Yeah.
And COD was the father of the relational model.
Exactly. So that award is basically one of the highest honors in data management research. It recognizes truly game-changing contributions.
Makes sense. You get that.
Yeah. And beyond the awards, she was known as a really respected mentor, and she played an important role in shaping the SQL standards, too.
Helping make sure different databases could, talk the same language.
Right, ensuring more consistency. And even after her long career at IBM, she didn't stop. She stayed engaged with data challenges, taking on roles at places like Paradata and Salesforce later on.
So let's bring it back. What does all this really mean for you listening, for the everyday users of technology? Why should we care about the nitty-gritty of database query optimization?
Well, if you connect this to the bigger picture, just think about how often you interact with a modern database.
Probably constantly, without even thinking
Like
about that.
countless times a day, yeah. Every single time you search the web, buy something online, use a mobile app,
Hmm.
you are directly benefiting from the innovations Patricia Selinger pioneered.
Hmm.
Her work is really what makes things like data science, big data analytics, even cloud computing as scalable and, frankly, as accessible as they are today.
Can you give us a sense of the scale? Like, how much data are we talking about being processed using these ideas?
Oh, it's staggering. Just consider the sheer volume of data being processed globally, like every second.
Billions, trillions.
Billions upon billions of queries run daily across every sector imaginable: banking, logistics, healthcare, advertising, you name it. And the fact that these queries can often be processed with such speed and efficiency, getting us the info we need almost instantly, that's a direct result of the foundational work laid down by people like Patricia Selinger.
So without her contributions,
Yeah.
the digital world would be...
Likely significantly slower, less reliable, and much, much more complex to manage and use effectively.
So really wrapping this up, it's not hyperbole at all to say that Patricia Selinger didn't just make databases faster.
No, not at all.
She fundamentally transformed how we interact with information on a truly massive global scale.
That's precisely it. Her
Mhm.
work was critical in taking relational databases from this promising academic concept
Yeah.
to a practical, high-performance technology that really does underpin so much of our modern digital world.
It really makes you think, doesn't it, about all those unseen layers of technology just humming away, powering our daily lives.
Mm-hmm.
What other seemingly invisible innovations have had that kind of transformative effect, quietly shaping the world we take for granted? That's definitely something to chew on.
A great question to end on.
Thanks for taking this deep dive with us today.